Hello everyone. Very good evening. I hope you can hear me well.
Yes, ma'am, you are audible.
All right, great. So let's begin the session today. So, just a second. Yeah. All right. So, for those of you who did not join us last time, let me give a brief introduction on what these sessions are for. So you've all, taken this course called Introduction to Biostatistics, and so weekly you get a set of lectures. You watch those, and you're supposed to, at the end of the week, as a form of assessment, you were given a short assignment. And if later you are interested, you can register for the exam and appear for it, and you get a certificate. So just to improve the understanding of, just to improve our understanding of this course, one second. Yeah. So to improve the understanding of this course, the NPTEL team has decided that for all these courses, every week, once it has been a few days that the week's material has been released, we would have a live session, and you can attend this. So wherein basically we are going to revise, and if there is, yeah, I hope you can still hear me. There was some disturbance in my earphones. Can you confirm? Can one of you also unmute yourselves and say, I am not able to hear you, it seems. Oh, I'm not able to hear you. Wait, let me put on the earphones back. Okay, sorry for this. Yeah, I think I can hear
we
you
can
now.
hear you, ma'am.
Yeah, I can hear you now. Okay, sorry for the interruption. Okay, so I would just request all of you to mute yourselves unless you're asking a question. All right. Okay. So yeah, so these live sessions are basically for us to revise the course contents quickly. And if there are any questions that you have, you can ask those, and we'll practice some questions and, just see if everything is going fine. All right. So we had one session last week. So this is the plan. So we are two TAs for this course. One of us are going to take sessions on Fridays, and the others are going to take on Tuesdays. So the idea is that you need to attend just one of these, whichever is more suitable for you. And of course, you're free to attend both of them also. So those last session, so the first week's both the sessions are over, and you would have been given access to a public sheet wherein there are links to um, the previous week's sessions. So in case that's not available, I will anyway share the link with you at the end of today's class. And so here we are today. So I'll be conducting this session for week two's lectures. And so this is an 8-week course. So we have 8 revisions, these 8 live sessions also scheduled. And if you want, of course, we can have a revision session at the end before your exam. Okay. So just for these sessions, the last week session was conducted. So this is a biostats course, so it's good if you can have a notebook and a pen and maybe a calculator ready with you. And so these sessions are on Zoom, as you've already joined this meeting. You can already see that the meeting is being recorded, right? And so this session is being recorded, and I'll upload the recording on YouTube once it's done. And this is the Google Drive's link. It stays the same for the whole course. So after every session, I will be uploading this PPT that we discuss. And if there's any other material, like an R code or an Excel sheet or any other material that we use in the course, I'll upload all of that. So currently, if you check these 2 links, it will have information from the first session. Okay. Again, if there's anybody with their mics unmuted, please mute yourselves. Yeah.
Can you put the link in the chat box?
Sure, I'll do that. Okay, give me a second. Yeah, so I need to stop sharing. Okay. So there you go. All right. And okay, yeah. I'll reshare my screen. Okay, so that's there. So now, if there's not anything else to discuss, we can start with a quick revision of the session. So these sessions are designed for something around 1.5 to 2 hours. But depending on if there's less to cover, we can wrap it up quicker. If there's more, it may extend up to 2 hours, but we won't extend anything beyond that. All right. So let's start. So there were about 5-7 terms that were introduced in this week's topics. So I'll quickly go over through those. So this is where we were in the last week. Like, so there's something called standard deviation, which is one of the several measures that you can have to tell about the spread of the data. Now, when we say spread of the data, as we also had a slight little conversation in the last week, that spread is a relatively informal term. It does not mean anything. The spread of the data is also sort of, you can also explain it when you say the range, but the range always does not do justice to data. So a standard deviation is a slightly better measure. It's sort of like it's taking into account all the points rather than just the end points. So we also discussed something that you have a population to begin with, and then if you select a few, you choose a few, you sample a few of them, so that smaller data set is called your sample, right? Yeah, right. So there's something called the population, there's something called the sample, and therefore for a population, you would the mean of the population is denoted by this mu sign. The mean of the sample is denoted by this x bar. Sorry. The standard deviation of the population is a sigma, standard deviation of sample is s, and correspondingly the square of these values are the variance. And this is just another way in which you can transform this and use. Now, once this is established, there is a theorem. It's known as the Chebyshev's theorem. It's a theorem, so it states something empirically, and what it says is that let's say you have any value k, and k just has to be greater than 1. So let's say k is 2, k is 3, k is 4. We take these examples. So it states that at least 1 minus 1 by k square proportion of the measurements will lie within k standard deviations of the mean. So let's see what this means. So this is your mean. And let's say when k is 2, what does 2 standard deviations from the mean mean? It means that mean plus 2 mu or mean minus 2 mu. This becomes a range, right? This is the mean, 2 mu less than that and 2 mu greater than that. This is your range. So there is a certain proportion of observations that is going to be within it. That's the whole idea of standard deviation in the first place, right? So now what is this proportion? So it says 1 minus 1 by k to the power 2, this proportion of the measurements, right? So now if you say 2, so it would mean 1 minus 1 by 4, which is 3 by 4. So 3/4 or 75% of the measurements, 75% of the data points. And so this is like a fixed value. You can maybe sort of remember it or just remember the formula. So this is sort of what the Chebyshev's theorem says. But now if I ask you that this percentage, shouldn't this depend on what kind of distribution we're looking at? Whether it's a uniform distribution or it's a normal distribution or a Poisson distribution, and there are so many of them, right? So would you say it should depend on the distribution or it shouldn't? What do you think with the lectures you've attended and in general? Because I can just try to draw an example here. So meanwhile, you can answer. Yeah. So let's say if I say, so let's say if I just say I have an observation like this, and I have an observation like, which has a little tail at the end. something like that. So maybe the standard deviations don't differ, but I do have some values, the extremes, right? So basically the type of distribution is going to affect whether this percentage that we are calculating from this point is actually true. So let's take an example. Okay, before that, so uh, like the normal distribution, which is this perfectly symmetric bell-shaped distribution. It goes on something like this. So this has different proportions from Chebyshev. So this is sort of already a proof that you know you take into account these two, right? So this is very different. So we also take an example. So let's say I have these data points. So what I'll do is I have entered these values in Excel. Okay. Yeah, here they are. Okay. Let me increase the font size a bit. Okay, I hope you can see the numbers now. Okay, now
Yes, ma'am.
through this, now when we're doing this activity, I would like all of you to be very interactive. So if I want to calculate something, if I want to see if Chebyshev's theorem holds, how do you think I should go about it? So these are my observations. This is the X value. Now, what all numbers do I need for Chebyshev's? So let's say I am taking the value of K to be 2, let's say, whatever. Okay, so that's K. What other measurements do I need for Chebyshev's? So what I'm talking about is, so here in this, here what numbers are you looking at?
We need mean, calculating the
Yes.
mean first.
Yes. Oh, I think I made a mistake here. This won't be mu. This is going to be sigma, right? I'm so sorry.
Sigma is this is the standard deviation.
Yes, sigma is the sample's standard deviation, and mean is going to be your X bar. Yeah. Okay. So, like you said, so let's calculate the mean. So, sorry. Yeah.
Yeah, sorry to jump in. Like since I joined little late, like 5-10 minutes back. So, could you just give me like this theorem since I'm not very
Sure,
much
sure.
aware?
Okay, sure.
Yeah, I'm so
No
sorry.
worries. No worries, no worries. That's okay. We just discussed, so you're at the right time. Okay, and also still mentioning that all the sessions are being recorded. So in case, if maybe your internet connection, you lose your internet connection or the voice is not clear, so don't worry. All of this is getting recorded, and I will upload it within half an hour from when the meeting ends. And I have shared the YouTube link in the chat. I'll share it again at the end in case some of you have joined late. All right. So yeah.
Thank you so much.
Yeah. All right. So from the last week's discussions, let's say we have established there's a formula for standard deviation. And so we are just talking about population and sample. Population means everything, but it's not always possible to take measurements from everything, all the data points, ideally possible. So what we do is instead we take a sample. We randomly choose a smaller set, and from that smaller set we can calculate its mean, which is denoted by X bar, as opposed to the population mean being denoted with a mu. And so the sample's standard deviation, which is a measure of spread of the data, is calculated through this formula, and the square of it would be variance. So now with that established, the Chebyshev's theorem states that you can have different, so it's basically to give you an estimate, that let's say this is a distribution and let's say this is your mean. So now let's say you go k times the, I'm denoting standard deviation by a sigma just to be clear, but it's the same thing. It's applicable to both sample and population. So you can go from mu, you can go k times sigma on the left, so that is you reduce it, and k times sigma on the right, that is you increase it. Okay, so let's say k is so this theorem only holds for values of k greater than 1. So let's say k is 2. So that means mu minus 2 times sigma and mu plus 2 times sigma. So let's say you lie somewhere here. So now how many data points are there within this region? Likewise, if you go k being 3 times, so you would go somewhere here and here. So how many data points lie within this region? So the proportion is determined by this fraction. So 1 minus 1 by k square. So let's say when k is 2,
What actually K means?
k is just a number. How many times, how much values you want to span. You want to go mu minus 2 sigma or mu minus 3 sigma, mu minus 10 sigma, how much of it you want to go. That's it. Okay, so k can be anything. It does not physically mean anything. Okay, so if you take k is equal to 2, it would mean 1 minus 1 by 4, which is 3 by 4. That means 3/4 of the observation, which is 75% of your observations are going to lie within this value. So by the way, just let's have this discussion again. When I am drawing this plot, okay, and when I say this is mu, can you tell me what is on the x-axis and what is on the y-axis? Because this thing is very important. Yeah. Can anybody tell me? We had this discussion last time also, but
On the y-axis, we have the relative frequency, and I think for the x-axis, it's like anything height, weight, something like
yes,
this.
perfect, absolutely.
Because I
measurement
just
value.
had the lecture today only.
Yes, yeah. So x-axis is actually the values that are there in your data set, right? For example, these values that you see on the left, these are your values on the x-axis. And so instead of, so let's say you had like a lot of data points, maybe like 1,000 data points. So on the y-axis is going to be your frequency, or you can have proportion that is between 0 and 100, or you can have between 0 and 1. So it's basically like a frequency plot. So you can imagine it to be like a super, nearby histogram, right? Remember histogram from the last week, right? Something like that. So you have, let's say it's between, let's say values between 1 and 1,000 with a, each of these bins is like 10 values. So between 1 and 10, you have 2 observations. Between 10 and 20, you have 5 observations, and so on. All right. So this is what it means, that when you go some distance to the left and some distance from the right, so how many values are really between this? How much of it is captured? So what Chebyshev's theorem indicates is it's telling you the significance of calculating standard deviation. So as you take more and more standard deviation, you cover more and more of your data points, which is what do you say? It's you can predict that. But now these values, we want to see that how accurate are these values? Is it an overestimate? Is it an underestimate? Or is it like accurate? Because the argument is that what kind of observation you have should, what kind of distribution you have should determine if these values are actually correct, right? If you have a normal distribution versus if you have a uniform distribution, I would not want to believe that this percentage is going to stay the same for both of them. For example, for a normal distribution, so if you see here, these two values, when k is 2 and when k is 3, here it's 75 and 85. On the other hand, I just made this mistake here. Yeah, right. So for, k value 2 and 3, there it was 75 and 89%. And instead here it's 95 and 99.7%, right? So the kind of distribution you have, it changes this percentage, but what Chebyshev's theorem says that at least 75% are going to be within that range, but that 75 easily turns into 95 for a normal distribution. So that's just as an example, and just to be sure that how do you calculate standard deviation, and how do you check this, we are going to do a small activity wherein we have these, I guess these are 15 observations, and we want to see if Chebyshev's theorem holds, and how different it is from, how different the real value is from what Chebyshev's theorem predicts. Okay. So yeah, so like we were discussing, to prove or to go around seeing how accurate Chebyshev's theorem is, there are certain parameters we would need to calculate. So like one of you pointed out, the first thing we need is a mean, right? And the other thing would be a standard deviation. So right, if like for the purpose of your exam, you would have access to an online calculator, so wherein you can just enter these numbers and divide it by the number itself. And yeah, so the mean in this case, so I'm just using Excel for it to be quick. So it's going to be is equal to, then there's this function called average, then a bracket, and then I'm just going to select all these values, and then I'll put a closing bracket and hit enter. So I get 22. So let's, for simplicity's sake, let's keep it 22. And the next thing I would need to do is find out x minus this mean, right? Correct me if I'm wrong, okay? Now, what I'll do is I'm going to write this value minus 22. So it gives me this value, and I'll do it for all the observations. So I get the difference. What would be the next step?
Square rooting.
Square root or square?
The square.
The square. All right. So I would find the square. So I'll just do this, multiplies by this again, and I'll extend it for the whole thing. All right. What would it be the next step?
You'll summation of all this.
Correct. Right. So I'll sum this up, and I'll select it, this. So that gives me the sum. What would be the next step?
Divided by the total numbers.
Okay. Now, will I divide by n or will I divide by something else?
1 minus
So
1.
sample, if it is sample, then minus 1.
Yeah. So yeah, so always we'll assume it's a sample. It's just 15 values. So it cannot be a population as such.
14.
Right? So yeah, 14. That's correct. So this divided by 14. So that becomes, and now finally what we are going to do?
Square root.
Square root, because we are finding the standard deviation. This is the variance, but we'll find the square root. So that is SQRT bracket, this thing, and you press enter. So that becomes your standard deviation. Okay. This is your variance. Perfect. Great. And now it's time to prove Chebyshev's theorem. So what we can do is, so let's say we want to find mean minus 2 times the standard deviation, and we want to find mean plus 2 times the standard deviation, right? So I'll do this is this value plus
22 plus 58. Around.
Yep. Not 58. This one,
5.
standard deviation.
Of 10.
Right? This would be minus, and then likewise this plus 2 multiplied by, sorry, this value. So is that correct? 11 and 32?
Just 10.8.
Yeah, you can see the formula here.
Oh, minus. Okay.
Yeah, minus and plus. All right. So it means we are interested in, so let's see how many values lie between 11.18 and 32.87. So out of these 15 values, how many lie within it and how many don't?
Almost all the value lies between.
Yes. So all of them, right? So we say it's 100%, right? So on the other hand, what Chebyshev's theorem predicted was that at least 75% of the observations will lie. So it's not wrong. It's at least, right? So maybe we can just say this, right? This is because what, So what this indicates is that Chebyshev's theorem is a relatively conservative estimate. It says minimum 75 is going to be there, irrespective of what kind of measurements you have, but it may be different. And so we have seen that. All right, great. And it was not very difficult to calculate all the things, right? You have your observations, you calculate the mean, then observations minus that mean, squaring it up, summing it up, dividing, root, and things like that. Okay, great. So now so there are a few more terms that we come across in this week. One of them being standard error of mean. Now, this is just a very, so it's basically your standard deviation dividing that by the root of our observations. So it's, now the thing is, now one can be obviously derived from the other as long as you are mentioning that I have plotted the standard error of mean or I have plotted the standard deviation. That's all that you need to show. This is particularly done. So let's say you have this bar plot and you would have seen, these bars like this. So now this bar can be actually your standard deviation or it can be your standard error of mean. Right? So it's up to you. Just mention what the bar indicates so that the right message is conveyed. Okay. Now, there's another important z-score. This in the, as of now, we don't exactly discuss the implication of the z-score, but just keep in mind that this is going to be very, very useful in sort of transforming the data. So now this is something you're familiar with, right? The numerator here. So now let's go to this Excel sheet and I'll just show you something. Yeah. So now what we did was we found the mean of this terms, right? We found this to be 22. What do you think the mean of this is? What do you think the mean of this term is? Any guesses?
Madam, is this mean deviation about mean?
Which mean deviation?
Mean of the x minus mean is mean deviation about mean.
I am not sure if I can understand that. Mean deviation about mean, probably. But I don't know. I'm not sure. I'll have to see. Mean deviation about mean. Let me check. Okay. But so
Another thing is there, no, ma'am, mean deviation about median. Every median value which is deviating from, how much deviating from each value, mean of that value.
okay. Okay. So the standard deviation that we have just calculated here, right? This one. This is the standard deviation about mean. Right?
Yes, ma'am.
Yeah. So for this thing, I'm not sure if this has a name. So this, I just want to tell you what it does. So now you have these values and you have just transformed all the values. You've just subtracted the mean from them, right? So if I take the observation, if I take the mean of this, so here we just took the first decimal place, but if you take it until 4-5 decimal places, this is going to amount to 0. All right. So what it means is that when you are doing this, the numerator here in this case, so corresponding to each observation, you now have observation minus mean. What you get is centered data, and the data is centered around 0. By default, any data that you had was centered around mean, because let's say we're talking about the mean as a as a measure of center. So now in this case, if you subtract mean from each of your observations, that data set, if you use instead of the original, it becomes a centered data set. And now on top of that, if you divide each of your data points by the standard deviation, then if you are going to find the variance of that data set, you would see that the variance and the standard deviation of the new observations now is 1. Right? So you have a data, you find the mean, and what we did, you found the mean and you found the standard deviation. Now from each of the values, you subtract the mean and you divide it by that calculated standard deviation. That becomes your new data set. So now if you check what are the qualities of that data, you would see that that data's mean is 0 and its standard deviation and variance is 1. So this is called centered and scaled data. And so Z score, you'll have 1. So that's the new updated value of each of your original values. And it said that in case, if still you have any data points which are either greater than 3 or less than 3 on either side, and that's sort of considered an outlier because it's too far away. So even after having your standard deviation and variance all around 1, so most of your data set is between -1 and 1. But still, if you have some values which are greater than that, it's an outlier. So what is normally suggested is that you found these outliers, you remove them, and you recalculate everything again. So because there's no point that you are sort of, we saw, right, that mean is sensitive to outliers. So, and there are a lot of things that you would see as the course progresses, that it is recommended that outliers should not be included because they're just skewing your data. All right. So just keep in mind the concept of Z-score, that the Z-score is nothing but it's data that is centered and scaled, centered around 0 and scaled to have a standard deviation of 1. Okay. And with that done, yeah. So then we come to the concept of, so box plots was one of the plots that was left in the last week. We discussed a lot of other kinds of plots, right? Pie chart, line and scatter plot, and bar plots and histograms. And this box plot was left. So because there are a few things which are, it is important to understand to make a box plot. So there are 3 values. So we're talking about a quartile system, which basically means you're dividing your data into 4 parts. Okay, so if I try and draw something, so now in terms of box plot, so the histogram that we just saw, right, and this thing that we just saw here, your observations were on the x-axis. Now in case of box plot, we'll have our observations on the y-axis. Okay, this is where we are going to have our observations. So let's say this was your highest observation, something around here, and this was those observations. So what it does is you are basically dividing it in terms of positions, right? So the value at the middle position, the value at the 1/4 position, and the value at the 3/4 position. So the middle one you're familiar with, it's the median, right? It's this thing. And then you can also have the one at the 1/4 position and the 3/4 position. All right. So now it's important to remember this. These, you first determine the position and then you pick on those values. So you have 3 values with you. The value which is at position 0.25 of the total, 0.5 of the total, and 0.75 of the total. So this becomes your Q1, Q2, and Q3. So Q2 is synonymous to median. So Q2 is not as such used. So you just focus on Q1 and Q3. And now what you do, you have these 2 values. Let's say it's, so the Q1 and Q3 values, you subtract this and the value that you get is called IQR, the interquartile range. And now if you subtract from Q1 1.5 times of IQR, that becomes something called a lower fence and something called an upper fence. Any question? I'll just mute everyone. Yeah. So once you have asked a question, you can just mute yourselves and then unmute again whenever you have another question. Okay. So basically what a box plot looks like is something like this. Okay. So this is your Q3. This is Q1. This is your median, right? And this is your upper fence, and this is your lower fence. And now, if there are still any observations which lie outside the fences, it's marked with a star. So let's say there were 2 points here, there was 1 point here, this is how it was. So this is how you make a box plot. All right. Yeah, that's it for the box plot. Any questions? So we will see, making box plots a little bit today when we start working with R, and in the upcoming classes. So if there's no question, I'll move to the next topic, which is moments. So there is this general formula of a moment. So a moment, which position, like which number of moment, which is R, and around what or about what. So this is a formula. Now, when you're finding the moment about 0, so the first moment about 0 is the mean. This is the formula for the second moment around 0. This is going to be used somewhere in one of the standard deviation calculations and things like that. And you can also find moment about the mean. So wherein here this A becomes your mean, right? This y bar. Don't get confused. Like I've used y instead of x here. It's the same thing. Okay. So now if I put the first moment around the mean. So if you calculate this, so it's summation yi minus y bar. And the summation sign can go inside. So it's going to be summation of yi minus summation of y bar. And if you sum up yi, that's also going to give you the sum of all the observations. And if you sum up y bar, that's also going to give you sum of all the observations, right? And even otherwise, we saw that this thing, right? We just saw the sum or the average of this value. Remember the second column we had in Excel? This was our second column. So if you add up, it is centered around 0, right? So the sum, the average, everything is going to be 0. So the first moment about the mean is 0. Likewise, if you calculate the second moment, you would see this thing is your variance. It's the square of standard deviation. And you can see from this formula itself. So for symmetric distributions, you can imagine. So there's an observation, let's say the mean is 5. So there's an observation 1 less from the mean on the left and 1 more from the mean on the right. Right. So if you have something like a odd power, so -1 to the power 3 plus 1 to the power 3, it's -1 and 1, so they cancel. Or -2 to the power 3 and +2 to the power 3. So they'll have the opposite signs. So when you sum it up, it's going to cancel to 0. So odd moments about the mean will be 0 for symmetric distributions, not for all distributions. All right. These are just some empirical observations that you can keep in mind. But rather than remembering it just like that, it's better if you can remember it. Remember why this is happening, because of this formula. So this is the formula that you should just remember. All right.
I mean, general term, what moment do? Like you tell standard deviation is the spreadness and moment is actually what?
Good question. I never thought about it. That's a very pertinent question. I think I might have read about it somewhere, but I'm not able to recall it at the moment.
No problem.
Yeah. But
and
I'll keep this in mind. Yeah, sorry.
How it's possible to I don't know about understanding all the formulas and learning these things. Yeah.
Okay. So you would appreciate this more when later in the course you would see some applications, right? So like I can speak from experience. So I have also had courses of biostats in my undergrad. But now when I'm a PhD student, so now when I'm doing my work is in the field of bioinformatics, so I'm heavily using a lot of these concepts. So for example, Z-score that I just told you about. So I studied Z-score maybe like 3 years ago. I've been using it for the past 1 year, and for this like when I went through this week's lectures, I could really relate and understand it better, right?
Yeah, of course.
So right. So
and,
yeah.
Yes. Would it be possible that the like at the end of the week, what assignment we get? Na? Can we discuss those questions also?
Yeah, sure. So the thing is, we can discuss this once the assignment deadline is over, not before
Of
that,
course.
right?
Yeah.
So as you know, the deadline for week 1 and week 2 is both the 9th of August,
Hmm.
right? So that is, so so the day when we are discussing week 3's topics, then we can
Yes.
discuss week 1 and week 2's assignment also. Sure,
Done.
absolutely.
Done. Done.
Yeah.
Okay.
All right. Yeah. So the last two concepts that are introduced, these are just, again, these are measurements. If you can ask me how will this be used exactly, this I'm not, again, we'll see as it comes, but these are again just some measurements to explain the data. So skewness basically means the shift left or right. So it's given by this formula here. And before that, yeah, so you can just check that, each of these moments, because you're squaring it up. So here the value of the unit of moments is going to be square of the initial unit. And M3 is going to have, the cube of that unit. So on the other hand, both this, so skewness and kurtosis, both of these have the same unit as your starting material, like your starting data, right? So it's moment 3 and the 3 by 2 power of moment 2. Likewise, this is moment 4 and 4 by 2, again, which is 2 square of moment 2. So skewness, this is sort of giving you an indication of if it's shifted to the left or right. And kurtosis is a measure of, do you remember what this gives? Yes, somebody raised
Fatness.
hand. The peakedness, how peak it is, right? So it's this or it's this, something like that. Yeah, one of you raised your hands.
Yes, ma'am. There is another formula for the skewness, that is Kerr-Pearson formula, that mean minus mode by standard deviation, right? So if I
Right,
face
right.
any type of such problem in assignment or any other in questions in the exam, so
Mm-hmm.
by which method we are going to do that?
Okay.
By moment or by the Kerr-Pearson?
Okay.
And for kurtosis also, this is the same.
Okay. I am familiar with those formulas. And do you think it will give us the same? So basically, the idea is, so if you would have a formula when you need to calculate this, it is going to be a relative thing. Okay, maybe you're given two distributions. Maybe you're given moment 2 and moment 3 for both of them, and you are asked which of them is positive, which is negative, which is higher or lower, and it's a relative thing, right? Because the absolute value, I'm not sure how important that would be. I mean, if you're looking at just one, just one data set at a time. So if that is so, what I would understand is that you can use either formula. It's just you use the same formula for both your data, and it should not be a problem. Yeah.
Ma'am, but if I do it by Kerr-Pearson method, and if I get such other answer which is not enlisted in the MCQ, then
Right. So like I mentioned, the absolute value of skewness, I'm not sure if that is something that would be important. But let me check. Okay. So it's a valid question, because yeah, if you have two formulas, there should be either a connection between them, they should be related, or you should be, maybe explicitly asked that do it only through this formula. So I'll check and I'll let you know over the discussion forum, right? So I hope all of you are familiar that there's a discussion forum um for each course that you have on NPTEL, right?
ma'am, another thing that
Yeah.
if there is a sample is given a number of series of number like this, and if they say that we in the two standard deviation, how much value is lying? So
Yeah.
for that, will you do that Chebyshev theorem, or should we do it by calculating that mean standard deviation, and after that within the two standard deviation how much value is falling in that?
Okay. Okay, good question. So now if you are given the exact points, like what we did for Excel, so in that case, you can do the exact steps that we did. You find out the standard deviation, you find out the mean, and then you see mean minus, let's say, 2 standard deviation, mean plus 2 standard deviation, and then you count. But if you're not given these exact points, then you will have to use the Chebyshev's theorem. That would give you an estimate.
Okay, ma'am.
So positive and negative, just the value. A3 being positive, positive skew, A3 being negative, negative skew. Yeah. And the formula, the link for the discussion forum, I will just share with you in a minute. Okay, there's one more concept let's just discuss, right? So, yeah. So now we talked about the variance, right? The variance, which is the square of standard deviation. So now there's another formula which talks about the covariance, just like looking at the trend of both the observations. Now, how this formula is derived is not relevant at the moment. So now if you just focus on the formula, can you tell me what would be the units of this covariance, and what would be, is there like a minimum or a maximum value of covariance that you can have? So basically what I'm interested in is, let's say you have a value X, set of points X and Y, and you have these paired observations. So paired observations are those that you can plot as a scatter plot, right? So the first value of X is, let's say, is here, and it's something like this. So let's say if X is 2 and Y is 1, I plot it here. When X is 4, Y is 2, I plot this here. When X is 3, Y is something like this. So, this is what a paired data means. For every value of X, you have a corresponding value in Y. So let's say I have this. Now, I just want to see what a common trend. Do they follow like a similar trend? When one increases, does the other also increase? So covariance, which is this formula, it looks good, right? So, but can you just tell me, what do you think would the units be in terms of the units of X and Y? And do you think this number has like a lower limit or an upper limit to it? Or do you think a lower and upper limit is even important? Okay, first about the units. So what would the unit of this thing be? The first in the bracket. Let's say the unit of X was kg. It was weight of something. So the unit of xi minus x, which is
kg and the weight.
Yeah, kg itself, right? So xi minus x bar will have the unit of x itself. Likewise, this will have the unit of y. So the unit of covariance is going to be the units of x and y multiplied. Great. Now let's say if instead of kg and meter, I use pounds and inches. Okay. So my covariance is going to change, right? Because these values are different now. The units are also different. So I'm not sure if I would, if it's going to give me the same, it won't give me the same value, right? So it would be the same data, but I would get different values for it. So that's not correct, right? And likewise, so let's say in one case I get 50, in another case I get 55. I'm not really able to compare it. So instead of using covariance as a measure of similar trends, if you want to find similar trends, the other thing is called correlation. And there's a very simple transformation of this. So covariance is denoted as S with a subscript XY. And you know what this denominator here is, right? What is this on the denominator?
Standard deviation of X and Y.
Perfect. Right? So you divide the covariance by the standard deviations of X and Y. So now what is going to happen is that this becomes a unitless quantity, no longer dependent on units. And you would also see that the value lies between -1 and 1. Okay. So if you have, a set X and a set Y, and if you find out the correlation coefficient for them, and if you see that the correlation coefficient is something like 0.9, you would see there's a very strong positive correlation, something like what we drew here. And on the other hand, if it looked something like this would be a negative correlation, right? Because negative indicates when one is increasing, the other is decreasing, right? So if you go in this direction, you would see that as Y is decreasing, X is increasing, right? And finally, if there's a distribution which is all over the place, you are fitting a horizontal or a vertical line, then there's no correlation. So the value, the correlation coefficient value would be something around 0, maybe -0.2, maybe +0.2, but it's not considered to be a strong correlation. Okay. So now the next part of today's session, we're going to focus on R, and this might take a while. So for those of you who are on your laptops and would like to work along, please let me know if you have already installed R and RStudio, and if not, we will walk through it. No worries. Can some of you tell me?
No,
You've
no.
not? And would you be interested in installing it right now?
Is it
going
possible
to
on the
do it.
laptops also? Because I've heard it's like taking enough space for
No,
better
not
for
at all.
desktop.
No,
Okay.
not at all. R is
Yeah,
a
yeah.
relatively simpler tool. Okay.
Hmm.
For installation and for the initial things that we like, just for installation, you would need the internet. So so what I can recommend right now is so let's
Ma'am,
go
we
step.
can do it on the cloud, na? POSIT. On POSIT cloud, we can run the R. There is the R compiler.
Yeah, that is also an option. Okay, whatever
Can you
you
send
prefer.
us the
Do you
link
Yes,
have
from
a
where
yes.
to
you
download?
have R for the MacBook?
I will just walk you through the whole process. I have a few slides prepared, right? Don't worry. So because we have enough time also. We can easily spend like around half an hour figuring this out. So you can start installing it now. Okay. So let me just give you a brief on what R is. So like you've seen all these statistical things that we did. Of course, it's possible on Excel, but as you have more and more data points and you want to do like more complicated analysis, doing it over Excel is not always possible. So you need one of these, statistical tools. And R is a command line tool actually. So wherein it's not clicking, but it's actually you need to type that, enter this value, or things like that. So now yeah. So this is the link. I will just share the link, or you can just type it on your on Chrome or whatever web browser you use. Chat. There is R for Mac also. Yes, I will. So if you open this link, r-project.org, if you wish, you can install it along with me, or you can look at these steps. Anyway, the video is going to be uploaded. You can do it at that time also, right? Because it might take a while depending on the internet speed. It's not a super small software also, but don't worry, it's not very memory intensive, so your laptops would not hang when you use R. Okay, unless you load a lot of data on it, it won't hang. Okay.
For
So
Mac, should we go for rproject.org Mac?
let me just walk you through. Give me a minute. Yeah. So now this site that you open, r-project.org, so you can see a lot of information about it. So now basically what we want is, so here you see this link, right? Download R. We click on this, so it's available for Unix, Windows, and Mac, all of them. So you click on download R, and now you can see these mirrors. So what it basically means is, now R is being used by so many people, and so many people are going to, install R, and lots of things associated with R can also be installed. So to avoid one server being overloaded, a lot of countries are hosting the same thing. So you can install R from any of these places, right? So there are a couple of mirrors, as they are called, from India. One is from ICTS and the other is from NICER. So you can click on any one of them. For that matter, you can click on any of them. It does not matter, right? So let's say I click on one of these from India. So now when I open this, the first 3 links that I get, I can click on any of them. All right. I mean, I have to click the one which is applicable for my operating system. So for those of you on a Linux system, the first one, Mac second, Windows third. All right. You click on this, and you will have to install it, right? The installation wizard. So I already have this, so I would not be doing this step, but it should be straightforward. If you get stuck anywhere, you can let me know. And now once R is done, only then will we go to the second step, which is RStudio. But let me wait here, and we'll discuss RStudio a little later, because what we want to discuss with R is actually not entirely dependent on RStudio. So let me just show you what R looks like initially. So what I'll do here, I'll just search for R.
Can I
There
have?
is no option for installing.
Yeah,
Hmm.
I'm worried about like the Apple, if you have
Your voice is
M1
breaking.
chip or M2 chip. Can you hear me now?
Yeah. So the M2 chip is the newer one, the most recent
Yeah,
one.
so
Like,
I'm looking for the M2 chip one only. So
yeah,
maybe
whichever
because
one
of our
it is.
internet connection. Okay.
Yeah. So it's okay. So maybe installing it on the go right now is not the best idea, because it will take a while, and it's
Yeah.
possible that in the hurry we may all get stuck and get buried. So let me show you these steps, and I can assure you that there are tons of resources available online that will help you troubleshoot in case you get stuck. Okay, it is not at all a difficult thing to do. It's a very straightforward installation. Okay, so once you have installed R, what you open is just R. Okay, so you can see this thing here. That's a capital blue letter R. Where did it go? Yeah, with a like a gray circle on it. So I'll open that, this symbol that you see below. Okay, so this is what it opens. It says something. It says a version of R. It's a free software. Yeah, you don't have to buy. It's entirely free, and so there are just so many things that you can do. Now, when you want to start typing something, this greater than symbol that you see at the beginning, this is very important. So it says now you can type. I'm not doing anything at the back end. I mean, this is what R is saying. I'm not doing anything at the back end. I am free, so you can type. I'll, perform the job. So what do we do in R? So what we do is basically we are working around with some data files, right? Yeah. Okay, right. So we're just working around with some data files. So before doing anything, let's try something very simple. So whenever you want to enter some data, it needs to be stored locally as with some name. So simple names A, B, C, D, list 1, list 2, value 1. That's up to you. So let's say I want to save the value 5 to a variable A. So what am I saying? Save the value 5 to A. So in simple terms, I can write A is equal to 5. And I enter it. And now I want to see, did it do that? Did it really save the value 5 to A? So I'll just say, okay, show me what A is. So I'll just type A and I'll press enter. And it said yes. So A has this square bracket 1 means A has one value in it, and that value is 5. Now in R, there is one more way where you can assign this thing. It's called the assignment symbol. So it's basically, so there are a few rules which are associated with any programming language, that this is how you should write. You should have a bracket, you should have a space, starts with this, ends with this, things like that. That's called a syntax. It's, like the formatting rules. So by that syntax, the variable or the name of that, the named variable, it usually comes on the left. You can't put it on the right, but for all practical purposes, remember it's going to be on the left. So let's say now we say, I want to assign the value 6 to a variable called b. So I'll write b, and I want to assign it to b. So I'll put this arrow here, which is nothing but the less than sign followed by a hyphen, right? The less than sign is just next to m, and the hyphen is just next to 0 on the top. So I have these values and I say 6. So you can see this arrow, like this direction, right? Assign the value 6 to b. I enter it. And then when I want to see if b actually has stored that value, I'll just write b and I'll hit enter and I'll say, oh yeah, b has stored 6. Okay. With me till here? So for those of you who are familiar with some other language in programming, this would be simple. But for those of you who have never had a programming language experience, this can be difficult. So you need to tell me if I need to explain anything again. Okay. There are very basic things that we would be covering today, just to give you an overview on what are, what all you can do in R, the basics. Yes, Ruchi, you have a question?
Yeah, thank you. So the thing is that as we are being exposed to the programming R here, so I don't know if it is too early to ask, like in the like the written exams which we are going to have in later in September. So is it the R going to come? Are we going to use there?
No. I am not sure, like, if you can have some questions from R, just some basics, but
Theoretical.
theoretical questions, but you would not have to open R in that. That's not going to happen. Right?
So
the
So
exam would be objective or subjective?
I think objective.
Okay.
Yeah. But this question, I think, would be better answered if you ask it in the discussion forum. Oh yeah, by the way, I'll just show you the discussion forum also. Please remind me at the end, right? It'll just break the flow right now. I have the link open, so I'll just show it to you. But please remind me at the end of the session. You will have, for calculations, you will not have the Excel sheet, but you would have an online scientific calculator. So you can just sort of enter the values, sum, divide, square root, things like that. Yeah. So yeah. So R 4.3.1, yeah, I think that's the latest version. So anything above R 4.1 is good, if you already have like one in your system by any chance. Okay. So now, again, please tell me if these two things we did is clear to every one of you. Yeah.
Yes, somehow.
Somehow. Okay, fine. So basically, thing is, if I want to add or subtract something, let's say, let's try and calculate what we did in Excel. Okay. So what I can try to do here is, I hope you can still see my screen. Yeah.
Yeah.
Both the
Yes,
things on
yes.
the side, right? And it's not too, the font is okayish. It's
Fine.
Yeah.
readable. Yeah. Okay. So now what I did right now was I assigned a single value to this variable. So the value A, there's some value to A, there's some value to B, but it's a single value. Now let's say I want to have a variable X, which has all these values. Because it doesn't make sense I call this X1, then X2, X3, X4, X15, right? It's just too much work. I'll have to write this each and every time. So let me put all of these values as in X. So it's like a list. Instead of a single value, I'm storing all of these values. So what I'll say is X, and I want to assign a value to X. So I want all of these values. So again comes a syntax here. So now before I go there, can you see, so if I just show you this text here on the right, what symbol do you see recurring very often in this?
This bracket type thing.
Yes, right? This curved bracket. This is above 9 and 0 on your keyboard, right? The curved bracket. So this indicates that you're asking R to do a function, to run a command. Okay. So now the command that I would like R to do right now is I want R to combine all of these values as a list. So my step is combination. So it's called as C for sure. In short, it's called C. I'll put a bracket and I'm going to enter some values. So for simplicity, I'm not going to enter the decimals here. I'm just entering a random value. So let's say 26, again 26, 14, 29, 19, 22, 21.
Can't we do copy paste also?
I would need to put commas in between.
Okay.
Right, so it's just going to be messy. Anyway, I've just entered a few values. I think 9 values I've entered. That's fine. So what I'm saying is so when you are reading our command, you read it from right to left because you're assigning it on the left, right? So you're reading it from right to left. And as also is done in BODMAS, you read it from inside to out, right? You read the brackets, right? And then you come out of the bracket and then you read it, something like that. So these are my observations. What do I do on these observations? I perform this function on these observations. So I combine them. And then what I do once I've combined them, I assign it to a variable X, or I store it in the variable X. And I'll just hit enter now. And now if I see what does X have, so here I'm going to see that X has 9 observations, right? First, second, third, fourth, fifth, sixth, seventh, eighth, ninth. So this is a list. Now what I can do a lot of steps on this. So just like you saw here on Excel, is equal to mean, is equal to average, square, square root, dividing, all of that I can do on R also. So so this greater than sign, you can imagine as an, like that initial is equal to that you have in Excel. So what I can do is now, so if I would have just written this, if I would not have stored it in X, so I'm just copy pasting it again. So what do you think would happen? I'm saying combine them, or actually, let me not do that. It's just going to get complicated. So let's say I write, I say y is equal to a plus b. Okay. So what value does y store? 11, right? Sorry. And now instead, if I would have just written a plus a, let's say, I'm not storing it anywhere. I'm just saying compute a plus a. So that's 10, right? But it's not storing it anywhere. It's just calculating it and it'll just print it. So you see the difference here? Here I'm calculating and assigning and then printing. Printing basically means displaying, right? So calculate, assign, and then in the next step, I'm saying display it, show me what the value is. Here in this case, I'm just saying compute it, but since I'm not storing it anywhere, so by default, what R does is it prints it, it shows it. Okay. Is this somewhat making sense? I know it can be difficult at the first go, right? So, all right. So now what I can do is, so whenever I'm not, yeah, sorry.
Sorry, yeah. So I have a I use data mostly. Okay. And I mean, I have been exposed to R like not very much in deep and detail. So I'm like, where do you use R and where? I mean, definitely Stata we use in statistical or during our all my statistics and all. But I never had a chance to use R. So I'm just like, curious about where should I use R now?
Okay. So now I'll just explain it for you. I'm not sure if everybody else might be able to appreciate it at the moment. So are you familiar with the concept of packages and libraries in R?
Not really.
Okay. Uh, okay, fine. So I just told you that this curved bracket indicates commands, right? Some functions, some commands. So there are a lot of these commands. Okay, we'll see some of them in the next few minutes, but there are a lot of them. Now, I can say from experience, so I work in the field of bioinformatics, and there are a lot of functions developed specifically for bioinformatics. So you have, let's say, some gene expression data, and you want to work on that, you want to analyze it. Okay. Or there's also a lot of use of R in economics, some predicting trends, not just simple biostats, not just simple stats for that matter, but something else in economics I'm not entirely familiar with. But rather than performing the basic stats, you can add on one more layer and analyze field specific data. But
Okay.
we are a long way from that, right?
Yeah, because definitely you might be aware of Stata, I'm sure.
Mhm.
Because in the Stata you go, you didn't, even though if you don't remember the commands, you can easily go with the tools and select the summarize statistics and all those
Yeah. So
so
R is a command line tool, right? There's very little
tools been given here.
yeah. But if time permits, I will show you some things that R does offer, which
Okay.
sort of is in that direction.
Okay.
Okay, right. So what we are discussing, so let me just quickly summarize this before moving ahead. So you have to, when you're working with values, it's always good to assign them to a variable and then work on it. Like in this case, if you want to find the value of two numbers, like the sum of two numbers, we assign them and then sum them up, and then we can just check the value. So now in terms of, so when I'm putting the assignment symbol, I will not have an output. But when I'm not putting this assignment symbol, when I'm just, saying calculate something, when it's just the right side, then I will see an output. So now let's say I want to find the length of this whole thing. So basically I want to find the length of X. So there's a simple function, length. It's a command, so I need to put the curved bracket, and inside that I'll write X. Find the length of what? I want to find the length of X, and I press enter. So it says 9. And yes, indeed, I have 9 values here. Okay. Likewise, there's another function which can find the mean of X. Right? We calculate the mean here. So we can find the mean of X, and it's this number. There's also, I think, now the next thing is, yeah, sorry, Ruchi, you have a question?
Yeah, I'm so sorry. Yeah,
No
when you
problem.
said length of X, 9, so isn't it the observation we call it?
Yeah. Length. So the length means the number of observations. The length of the list, for that matter. X is a list, and I want to find the length of the list.
Yeah.
So if you work on a different like a different language, if it's a different language, R other than R, like C, C++, Java, or anything else, it's quite possible instead of length, it's called something else. So I understand it can be confusing. So but here I just want to, the main idea of this thing is just to give you an idea of what R does, what all R can do. Don't go into the absolute details of this, because again, everything that we are showing here, there are a lot of other languages that you can use them in, right? Yeah, just len, it can be len also. I think R also supports that. But again, so these details would come more into use once you actually start using it for your work. Okay, or once you formally start learning it. Here it's just a very brief introduction. So if this interests you, you can always there are more courses that are targeted towards learning R. You have lots of tutorials available online that you can learn R with. Yeah, but that's a good point. Right? So what I mean by length here is, so X is a list. and I want to find the length of that list. And mean here means I want to find the mean of the observations that are there in that list. That's mean. And likewise, I think there's a function called variance. So I can find the variance also. So it's something like this, right? And of course, I can find the square root. That's SQRT. Now I want to find the square root of this number. So one option I have is I can do square root bracket and I copy paste this number here. Or what I can do is I can have a variable v wherein I'm storing the variance of x, right? I enter that. And then what I do, I find the square root of the value v, right? So it's giving me the same value. Yeah, just for one extra decimal place. That's not important. But yeah, right? With me till here?
Yes.
Yeah, okay, good. So,
I mean,
yeah.
Honestly, I mean, I have been very much been familiar with the data. So, I mean, like looking at the means and variance, it could be easily calculated.
Yeah. So R is a programming language, right? So the the importance or the essence of programming language comes up when you're doing several things at the same time. Simple things like these you can also calculate, like square root, and mean is basically sum and divide, right? This you can also do in a calculator.
Absolutely, yeah.
But then more complicated things, which I am not sure we would be discussing today. So that is where the true essence of R comes up. I would love to share all of that with you, but it's out of the scope for this course, right? But anyway, right? So as one of you asked for the mode also, yeah?
Yes, ma'am.
Yeah. So let's say if there is a function called mode here. So what are we going to give as the input to mode?
26.
Yeah, that's the output. So the input is going to be x, right? The mode is okay. Now this did something funky, and I don't remember what it did. It said numeric, okay, which doesn't make sense. So now another thing with R is, so let's say I don't remember what the function mode is doing, or is there a function which can give me the mode? So there's a very good helpful thing that R provides is this question mark. So you do a question mark and you write the name of this function that you are interested in. So I'm writing question mark mode and I'm pressing enter. So it started this pop-up help, okay? So this is not the mode that we were thinking about, right? So it's the description says the mode or the kind of type it is, right? What kind of data it's storing. So this is not what we wanted, right? So what we can do instead of mode is, there's one more thing. There's a function called table. Now, all of this is absolutely new for all of you. You're not expected to remember this, by heart, because, one tool says this is the function to find the mean, the other says it's not, things like that. So there's a function or there's a command called table. Now, what table does is, table finds the frequency of each observation. So what it means is, we have 9 observations in all. And if we see how many unique observations we have, so we had 14, 19, 21, 22, 23, 26, 29, 31. So we had 7 unique observations with 14 occurring once, 19 occurring once, 23 occurring 6, and so on. So not the best way, but this tells us that there's one number called 26, which is occurring thrice, which is the highest occurrence, highest frequency. So our mode is going to be 26. Yeah, it's quite possible that there is another function which directly gives us that, but I will have to check. Okay. And while we are discussing all of this, let's check if median is a function. Like if median is, there. So median gives 26. So if you arrange this in ascending or descending order, so the middle term is going to be 26. So 26 is our median. Yeah, that's right. You are right. Yeah, R is really easy and it's the best free resource for statistics. True. Maybe I'm not able to convey it through these examples, but once you start using it, there's no going back. And okay, R does not have an inbuilt mode function. Median is available, so we saw that. Now, like you mentioned this inbuilt function. So I'm just telling you something. This is not relevant for the course, but it's worth mentioning. So like we just talked about, that R is going to be used in so many fields: biostats, economics, and I'm pretty sure it's a lot more. So now I don't need, so like one of you said that you've heard that R is a quite intensive software. So that may happen. So you see all of these functions are there in R, right? R has this, it's wherever it's stored on your system, it understands what sqrt means, it understands what var means, it understands what mean is, right? I am using 100 other functions that are relevant for me, but for somebody else they might not be relevant, right? Which are specialized functions. So I have the provision in R, I have the provision to only install functions that are relevant for me, and somebody else can install functions that are only relevant to them. So right now what we installed was the base R, called the base or the default R. And as and when you progress, there's an option to install certain, groups of functions. They are called packages. So let's say 100, 200 functions, or maybe just about 20 functions are set up as a package. So I can just install that package and then work with those functions. If I need a new function, I'll see what package it belongs to, and then I'll install that and things like that. Okay. Just for your information, not required at the moment. Okay. So this is there. Simple other things that you can do is find the log of some number. So let's say if I want to find the log of E. Oh, E, it does not recognize E. Okay, never mind. So let's say I want to find the log of 10. It's giving me 2.3. I want to find the log of 100. It's going to be this. So by default, so while I can see from this that it is calculating the natural log, which we often denote as ln. But let's say I want to be sure if it's really log of, the natural log. So what I'll do is I'll do this. This is one of my favorite functions. I will highly recommend you, whenever you are planning to use R, if you're planning to use R, you make use of this question mark. So log computes logarithms, and by default is the natural logarithms, right? But there's this other function, log10. There's another function called log2. So that is, the base is different, right? So instead, if I would have written log 10 and then found out the log 10 of 10, I would get 1, which is expected, right? Okay. So that's some of these things. I would also show you a couple of other commands that Sir showed in the class, in the lectures. Okay, so we just saw this function here, right? The C, like here. So now instead, if let's say I want to write all the numbers, all the integers from -100 to 100 in, let's say, increasing order. So now I'm not going to write -100, -99, -98, and so on. Okay, doesn't make sense. So the other option that R offers is, so let's say I have this. So what I can do, I can just write, it's always good to have it in brackets, -100 colon 100. And now if I see, yeah, right, -100. So now what these square numbers are indicating, they're just increasing the indicating the index or the position of the value. So the first value is 100. It goes on So I have enough space to just accommodate 8 values. So the 9th value goes in the next line. And then another 8 are accommodated. So the 17th value goes in the next line and so on. So the last observation here is the 201st observation. Yeah. So this is another way to have a list. And one more way which was shown, it was this function called seq, S-E-Q, short for sequence. So let's see what sequence does. So what it does is, now, so you need to, so this is the syntax. Like once you have the function's name, what do you write inside it? So you write from, so just remember, we wrote, right? From -100 to +100 and by. So by gives you the option of not just having an increment of 1, but let's say we can have an increment of 1.5. Okay. So what we can write is seek, and we put a bracket, and let me assign it to Z. Let me have it as -10. So it was like from is equal to -10, comma, 2 is equal to, let's say, +10. And I want an increment of, let's say, 1.5. And I want to see the value now. So this is the value. -10 plus 1.5 minus 8.5 and so on and so forth until 9.5, because if I add it one more time, it comes up to 11, which is more than what I gave as my upper limit, right? So this is just another way to write it. And there's one more thing you can do. It's called rep, short for repeat. So in repeat, the first thing that you write is what you want. So let's say I want 3. And the next thing you write is how many times. So let's say I want 3 to repeat 6 times. So something like this. Now, before I proceed, there are 2 things I would like to mention, and then we can take any questions. Let's say I'm writing something like this. Okay. So in this case, I had the number 3. It was numeric. So I did not enclose it in double quotes. In the second example, I had alphabets, right? So which is often called as characters or string. So here, when it's characters or string, you always have to enclose it in double quotes so that R, or for that matter, this is uniform across all programming languages, because HI here, it could very well be a variable, right? Maybe you could have named a variable HI. So that R does not get confused between HI as a variable and HI as the word hi, we enclose it in double quotes. So here we are repeating the word hi 6 times. Here we are repeating the word 6 times. So one more thing. Yeah. Now, if you take a look at this and this thing here, you can see that when I wrote seek, I wrote these things. I wrote a name, from, and I had an is equal to sign, and then I wrote a value. And then I had a comma, wrote the next name, is equal to, and a value. Here, I just had values, one value, comma, another value. So in this case, it's a named argument. Okay, by the way, everything that goes inside these curved brackets is called an argument. Argument of that function. Which function? This is your function. Anything before the curved bracket or anything that is followed by the curved bracket, it's a function. And within the function, you always have these arguments. There's a name and an is equal to before it. It's a named argument. Otherwise, it's an unnamed argument. It's just first argument, second argument, third argument, and so on. Right? So if I just change this here, now I could just remove these names and I would still get the same thing. But it's always better to have these names so you can even, alternate the order. Okay, maybe this is a lot of information. So just one more function that we can check. So this is, so especially when you want to find out the median, right? We check that the median of x, it came out 26. So if you want to check, we can sort x. So by default, it sorts in the ascending order, but we can also sort it in the descending order. We'll see how. So we have 9 observations. So the middle one is going to be our 5th observation, and we can see 1, 2, 3, 4, 5. This is there, right? So again, let's go question mark sort, because I want to see how do I make it in descending order. So when I do that, you want to sort it, and this is what it is. So by default, it's saying sort. The first argument is going to be the value that you want to find, you want to sort. And the second argument says decreasing is false, which means it's increasing, it's ascending. So instead, now decreasing false, what we can do is we can write decreasing is equal to true. So there are 3 kinds of values that any programming language understands. One is numbers, the other is alphabets or alphanumeric, which is called character or string, and the third is true false, Boolean. Okay, just consider it true false. So we can write sort x, and we can write decreasing is equal to false. Sorry, false, all capital. Oh, sorry. Decreasing is equal to true. Yeah, looks good. Okay, now I think this is all I had for today. To teach now, we just have a few practice questions to solve. But so again, mentioning, when you're seeing such things for the first time, it can be very intimidating, but don't get scared. I can only recommend you that you can try working on this whenever you get time. So we, in one of the, you would have seen that the console that Sir showed looked very different. So that's our studio. It has more features than R. So R is basically a language, and R Studio is just like a screen, a fancy looking screen that just helps you when you're working with a lot of things. But for the things that we discussed, this screen is good itself, right? So you, as such, for now, if you don't want, you don't need to install R Studio. This R, the R console that you see here, that's pretty good. If need be, in one of the upcoming sessions, if we have time, and if need be, we can discuss that. All right, but for now, this is all we had. I hope you got a little understanding of what R is. Okay, maybe not the best, but this is a statistical tool at play. Okay. Yeah, so now I will anyway be sharing this PPT with you. So yeah, so one thing I forgot to tell. So so I can okay, just one more thing I'll probably like to show you is how to make plots in R. So we have X and Y with us, right? So okay, what we can do is we can have a new variable Z, and let me just give it 1 to 9. Okay, so I have X here and I have Z here. The length are same. So let's say I want to plot X on one axis and Z variable on the other axis, basically making a dot plot. So not going into much details right now, but it's a simple function called plot. So it's a function, which means I need to have a curved bracket after it. So the first argument is X, and the second argument is the second variable, which I'll have on the vertical axis, which is Z in this case. And that's it. Okay, and I'm pressing enter. And there you go. It's a pop-up. Okay, right? So I have these observations here, I have this here, and that's my scatter plot. Okay, so likewise, there are lots of other plots. Of course, I can have all the plots we discussed: line plot, histogram, box plots, bar plots. We can all have that, but it's not required at the moment. Okay, so but for these plots, so by default, R does not allow plots on Mac. So this is another thing you would have to install, which is called Xcodes. That is all. For Windows and Ubuntu, this will not be a problem. You can have plots being generated by default. Just install this and forget about it. You won't face a trouble anywhere. Okay. So like I said, these PPTs I'm anyways going to upload on the Google Drive, right? So in case you get stuck, this is a short reference for all of this. You can have RStudio from here if you want. So this is what RStudio looks like. So what we, so what we saw a while back, which was the console, it's actually this bottom left part. So when you open R, it only offers this pane, this thing, whereas RStudio offers you 3 more things. But again, the thing is that, so I'll just, briefly tell you what it is. So now if I go back to the console and if I want to find out what all things I typed and remove everything that R gave me as an output, I'll have to, copy one line, copy another line, and so on. Instead, what R can offer me, what RStudio can offer me instead is I can write things here and they will run in this part. Okay, so anyway, it's just slightly more convenient. And then when I saved this in variables, right, I had variables A, B, X, Y, Z, and so on. But it's very easy that I can forget if I used A previously or not. So R by default here allows me to see the variables that I have here in the environment. And any plots that I make, they won't pop out, or the help menu, it won't pop out, it would come here in the bottom right? You can see plots and help and so on. So RStudio is just offering you a better screen. That's all. Everything what's happening is the same. R is the same. All right. So that's there. And so we've already seen these examples. Yeah. And we have just some practice questions from the part we discussed before R. Okay. So ready with your pen and paper, right? These are not very heavy questions, so I hope we can do them quickly. Yeah. So for a data set, the mean is 21 and the standard deviation is 4. And you have one of the observations is 25, right? It represents one of the values of the data set. Can you check if this value is an outlier? And the hint is that you need to use the Z-score. So do you remember what the formula for Z-score is? So can you just quickly tell me what Z-score does? It does 2 things to your data.
It tells whether one number is an outlier or not.
Yeah. Yes. And it does that by centering and scaling your data. It centers your data around 0. So which means
if any data of the Z-score comes greater than 3 or less than -3,
right,
then means that number is an outlier.
Perfect. Absolutely. So what we do is we find x minus x bar and then we divide it by sigma, right? So this numerator, subtracting mean from it, centers the data around 0, and dividing it scales the data to have for the new data to have a standard deviation of 1. So here we have, you can do this 25 minus 21, 4 divided by 4, that's equal to 1. So it's not greater than 3. So it's not an outlier, right? Good. Next question. This is the data set.
Can you go back and explain not greater than 3, please?
Okay, yeah. So by convention, it is said that, it said that if your, so what Z-score is doing essentially is that you're transforming all your data into a new set of data. If you had 20 observations, you have now 20 Z-scores, one corresponding to each observation. Now, if each of the Z scores, if they lie between -3 and 3, then they are said to be within a certain range, and they're not said to be outliers. Because Z score essentially is indicating that your data is now centered around 0 and the standard deviation is 1. So if a data is lying outside 3, it means it's three standard deviations away from the mean, right? Mean is 0, standard deviation is 1, the new standard deviation, that is, right? So it is too farther away to be included in our analysis. So it's considered to be an outlier. Okay?
Okay, yeah. And likewise, if it is less than -3, right?
Right. So it is, so the correct way to do it is 1 lies between -3 and 3. Therefore, it's not an outlier. Okay. All right. Next question is, so this is the data set given to you. What is the value of the lower fence when the data is represented as a box plot? So can you tell me what steps do I follow? What's the first thing that I need to do? So yeah, tell me the steps.
Calculate Q1 and Q3.
Q1,
Right.
Q2,
Enter
Q3.
quartile
Q1 and Q3.
Yeah,
IQR we
Q2
have to
can sort of
calculate.
skip because that's the median. We don't exactly need the median for this, but might
Q1
as
and
well
Q3.
calculate. Yeah. Okay, so just a word of warning before you do this. So whenever you are working with, a box plot or just calculating median,
Ascending order.
you need to ensure that your data is sorted. Okay, it's arranged in a ascending or
Ascending
descending
order.
order. I'm so sorry, I'm just muting because there's a lot of noise. You can unmute yourselves again. Yeah. Right. Yeah, you can unmute yourself now. Sorry. Okay, so what we have here is, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 observations. So Q1 is 0.25 into n plus 1, right? So that's 0.25 into 10, which is 2.5. So 2.5 lies somewhere here, right? And Q3, likewise, it's 0.75 into 10, so that's 7.5. 10, 9, 8, 7. So it's lying somewhere here, right? So Q1 is going to be 33 and Q3 is going to be 37, right? Right? 33 and this is 37. So the next thing to calculate is IQR, interquartile rate, which is 4. And the lower fence is what? Q1
minus 1.5 into IQR.
1.5 into IQR, which will be IQR. So that's, and my pen is not working today, so I'm using the mouse pad. So such a weird handwriting, but that's okay. 33 minus 1.5 times 4, which is 6. Right? So that's 27. So that's the lower fence. So what it means is,
We have an outlier 22.
perfect, right? 22 is an outlier because it's below the lower fence. Great. Okay, next question. So based on a data set given below, can you comment on the nature of correlation? Just want an approximate correlation. Positive, negative, that's it. Right? So while you can make plots, you can calculate things, but you don't need it. You just the nature, okay?
The order of y is decreasing as the x is
Negative
increasing.
correlation,
That's
ma'am.
why it's a negative
Perfect.
correlation.
Perfect, right? So it's a negative correlation. Right? Good. All right. And so simple, kurtosis is a measure of
Wickedness.
Even.
C, wickedness, not skewness. Yeah, wickedness. For a population that is normally distributed, the first and third quartile are 1500 and 5500 respectively. What is the value of the median? Simple. Yeah. Keyword.
1000, ma'am. 3000. If 0.25 is 1500, then 0.5 will be 3000.
Okay. Now 0.25 is the position. And 0.5 is also the position. It's not the value, right? You remember? Let me
That's the
just go through
Yes,
this,
ma'am.
right? Value at position this, right?
Yes.
So now the keyword here is normal distribution. So let me just give you an example. So again, I'm drawing this histogram, right? So let's say this is your median. This is Q1 and this is Q3. Okay. So that's 5,500, that's 1,500. And this, so normal distribution is a symmetric distribution. So Q1 is as far away from the median in terms of the value as is Q3. So not just position, but also value. So what we are interested in is the middle value between these two. Right? So you can find the average of this. So 1,500 plus.
Then 3500.
Right. Right. So that's going to be 7,000. And then you divide it by 2. So you get 3,500. Right? I hope you have all understood this. So again, caution, whenever you're dealing with median box plots, make sure if it's values, you make sure it's in ascending or descending order. And when you're making these calculations, be sure if the value that you're interested in, is it the position or is it the value itself? Okay. All right. Next question. For a distribution with mean 50 and standard deviation also 50, a value of 100 corresponds to what z-score? So again, simple, same formula, right? So x is 100 minus, you need to subtract the mean, which is 50, and then you divide it by the standard deviation, which is also 50 in this case, right? So 50 upon 50, that's 1, right? So that's there. Calculate the standard error of mean if these are your values. Do you remember what the formula of standard error of mean was?
Square root of standard deviation by n.
Standard deviation by square root of n.
Okay, sorry.
Yeah, no worries. Okay, so standard deviation is 100, and then the root of observation is going to be 10. So that's 10. Okay. All right. Next question. For a distribution with mean 100 and standard deviation 20, a z-score of 4.5 corresponds to what value? So now we might have to do simple unitary method for this. So you can also start doing it. I will also start writing this here. So 4.5 is equal to x minus 100 divided by 20. 20 into 4.5 is 90 is equal to x minus 100. Yeah, just cross multiplications. So x is equal to 100 plus 90, and that's 190. Right? Simple. Okay. Next question. How many modes does a uniform distribution have? Now, I'm not sure if you have been formally introduced to what a uniform distribution is. But if you can tell me, it's great. Otherwise, I can just show what a uniform distribution is.
1.
0.
Yeah. So uniform distribution basically means that all observations, you have all observations with the same frequency. Right? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for that, like that. Right? So again, here we are drawing the, like we're putting the frequency, and here it's your actual observation. So whatever observation you have, it's continuous. It's like one after the other, and it's with the same frequency. So all observations have the same frequency, so there's no one standing out. So the mode is going to be 0. Not unimodal, it's 0 modal, right? There's no mode. You can't have one value which has the same frequency. Okay, yeah, no worries. This was a slightly trick question, so no problem. Okay. And I think we have the final question now. Yeah. Oh, this one, simple. For a normally distributed data set, what percentage of data falls within 2 standard deviations? This is just a memory-based question.
95.
95. Yeah. All right. So I think with that, we come to an end of today's session also. So yeah, this session is being recorded. I will upload it to YouTube. I'll just share the link again in the chat box. And this PPT that we just have today, and the R codes that we wrote, I might probably take a screenshot of those and add it to the Google Drive, or I'll just add the screenshots at the end of this PPT itself. I think that will be better. And the Excel sheet also that we use, I'll upload that as well onto the Google Drive. And the deadline for this week's assignment is next Wednesday. And also remember that next Wednesday, it's also the deadline for the last week's assignment. In case any of you have missed it, you still have time. Okay.
The deadline for assignment 1 is also on 9th, right?
Yes. It's for the first 2 weeks, they have the same deadline, because just in case students are joining late. But starting week 3, so week 3's deadline is going to be like the 16th, week 4 is going to be 23rd, and so on. Yeah. So just in case you have missed assignment 1, or you would like to change some answers, you can try that again. And yes, I'm just sending you the links. Give me a second. What happened? Keep. So this is the YouTube link, and this here is the link to the drive. Currently, yeah, I just shared the link. So the Google Drive, currently it only has material from the last week. I'll upload this, and this Google Drive and the YouTube link also, it has only the recording for the last week's session. I'll just stop the recording and then I'll upload it within half an hour. All right. Any doubts? Any questions?
Thank you so much.
No? All right. Thank you so much. Very interactive session today. Good questions. I will try to look into some of the things you mentioned and get back if I find something. And all right. So thank you so much. The next session that I'll be taking is going to be next Friday. And anyway, you have sessions for each week on the corresponding Tuesdays also. The Tuesdays after the Fridays. So if in case you missed that, you are free to attend those as well. All right. Yeah. Thank you so much.
Thank you, ma'am.
Yeah. All right.
ma'am.
Bye-bye. Good night. See you next week.
Thank you, ma'am. Bye, ma'am.
Bye-bye.